Today we have Tobi Knaup, co-founder and CEO of D2iQ. Tobi, welcome.
Thank you for having me on the show. Great to see you, Lars.
It's great to have you, Tobi. And Tobi and I prepped before this call, and we today we're going to talk obviously about D2iQ, what you guys are doing, but also we're going to cover the greater cloud native and Kubernetes landscape. And we'll talk about a super exciting topic, which is smart cloud native apps. But I won't steal the show for Tobi. Tobi, maybe you can start just with giving us a little bit of background on D2iQ, the genesis of the company, what you guys are doing today, and then we can dive a little bit more into Kubernetes and cloud native. But let's start with the company.
Excellent. Yeah. So D2iQ has been around for 9 years. We're going to actually turn 9 years old in April. Originally founded as Mesosphere, that was our first company name, and we renamed the company in 2019 to D2iQ. So we play in this cloud native space. That means we help organizations build and deliver cloud native applications. Cloud native is an approach to building software and delivering software in a way that is, just born on the cloud, takes advantage of, some of the capabilities on a cloud versus, just lifting and shifting old applications onto the cloud. So, been doing that for almost a decade now. We're one of the first companies in this cloud native space, one of the pioneers, and, introduced a lot of firsts in this industry. We were one of the first to help organizations run some more sophisticated and advanced workloads in cloud native, like stateful and AI type of workloads. And right from the beginning, we've been partnering with some of the most sophisticated organizations in the world to really run mission critical applications. That's sort of our bread and butter. Our history actually goes back a little further than those 9 years, where my co-founder created the first freely available open source container manager as a research project, and before we were even a company. So been in this industry for quite some time, and have seen it evolve, and we continue to be at the forefront of it and be thought leaders.
Yeah. Well, you have some impressive logos on your website, right? I mean, there's U.S. Customs or Department of Homeland Security, United States Air Force. So definitely demanding customers. I'm sure we can talk about that a little later. Tobi, can you talk a little bit about, because you touched on a topic that I feel like is not clear to everyone out there, which is the difference between a lift and shift approach, putting a server into the cloud. It's not running in your data center anymore. Now it's running in AWS, it's a GCP's data center, and cloud native.
Yes.
I feel like that's not always clear to some people. Do you have some examples what the difference is and also the benefits?
Yeah, it's there's a lot to talk about here actually, because we talk about cloud native, and cloud can mean so many things, right?
Yeah.
I think one of the first companies that actually started talking about cloud was Salesforce, right? Where back then that was all about taking your CRM software, and instead of you as a company buying that software in a box and then putting it on your own server in your own data center, you would just let Salesforce do that for you, right? Like operate the software for you. So, and then of course we have public clouds like AWS and Azure and Google Cloud and others. So I like to think of cloud as sort of three different things. It's, first of all, it's a place. And then second, it's a way to procure. And then third, it's a way to architect, right? So let's go through these. So it's a place. It's essentially someone else's data center, right? You can go to a public cloud and rent servers or other IT services instead of you having to build and run that data center or operate that software, right? It's a way to outsource. Pretty simple. Someone else's data center. It's a place. The second is it's a way to procure. So that's typically around, instead of in the past, we bought big box servers, and then we bought, often perpetual software licenses for the stuff that goes on top. So we have these massive upfront costs, whereas in the cloud, it's more, metered, right? You pay per use, you pay per hour. right? So and you consume services instead of doing these massive upfront purchases. So that's second. And then third, it's a way to architect applications, right? And this is, to your question, where a lot of the difference exists between a lift and shift and a cloud native approach, because going with a cloud native approach means that when you design your application, you take full advantage of what's different and unique in the cloud, right? Full advantage of all those great capabilities. Versus, if you're lifting and shifting, the cloud, you're sort of using the cloud as someone else's data center, but you're not, following that cloud native architecture approach. So that's kind of the main difference there. And we can go into a lot of detail about what exactly it means to architect in a cloud native way. But I'll talk maybe about the business benefits, right? Like what is sort of the key reasons why people are doing that. And the number one reason really is agility. If you build in a cloud native way, which by the way means a lot has to change in your organization, right? It's not just using a new technology like Kubernetes, the key open source technology in this space, but it's really changing how you build and operate and deliver software. And if you do that right, it gives you more agility, right? So a lot of organizations typically move from only being able to make changes to their software, to their customer-facing applications, maybe once a quarter, to being able to do that multiple times a day, right? And think about what that unlocks in terms of capabilities, right? It's obviously a race out there. Everybody needs to build software. Software is eating the world. And so if you want to be at the forefront of whatever industry you're in, you need to be able to iterate quickly on your software and make updates to whatever it is that you're building on a daily basis, right? Great example there is what's happening with cars, right? Mm-hmm. If you buy a car from one of the more traditional car vendors and you want a software update on that, you have to take it to the shop, right? Yeah. If you buy a Tesla, it automatically gets software updates over the air, every 2 weeks or so. So they can only do that. Tesla can only do that because they're set up to, release software very often in an agile way. Mm-hmm. And that is sort of the difference, really, that cloud native enables. Is it gives organizations that agility that they really need these days to stay competitive. Lots of other benefits too, lowers costs and things like that. But that's the number one.
Right. Right. So the technology's there, right? It's been developed, it's out in the wild, but really it's the market pressure that forces these companies to reconsider how they're building apps and adopting cloud native technologies.
Yeah. That's absolutely right. Customer expectations have changed, right? And we can pick any industry vertical, right? Like, let's pick banking, right? I do most of my banking from a smartphone app, right? I don't go to the branch anymore. And I expect that app to get new features over time, right? Like, I can scan checks with that app now instead of taking the check to the branch and so forth. It gains more and more functionality like that. So, every insurance company now has an app where I can, interact with them and things like that. So really everybody has to do that and has to be able to, make updates to that very often.
Yeah, great. So I want to lead the discussion a little bit to what specifically D2IQ does in this area. And I think it may be useful if we touch on a few topics a little bit deeper. Maybe you can talk a little bit about containers, Kubernetes, just double clicking on these topics, what they do, and maybe some of the complications that arise from that. And I think that'll help us talk about D2IQ a little bit more.
And absolutely. Yeah, lots to talk about there. So one of the key enabling technologies for cloud native is what's called containers. And containers are basically a lightweight way to package an application. So it's sort of a standard way to package, whatever it is that you're shipping. Doesn't matter what programming language you use or really what's inside. And that's why we call them containers, right? They're like shipping containers. They all look the same from the outside. You can put whatever you want inside. So standard way to package those applications. And then it's a way to isolate different applications from each other too. So we can run multiple different applications on the same underlying hardware. They're isolated from each other. They can't see each other. And because containers are such a great sort of standard interface for applications, that means we can build a system, a platform that then dynamically manages those containers, right? Mm-hmm. Because they all look the same, we can do things like, move it from one physical machine to another one very easily, right? We were able to do that with virtual machines too, but not as fast, not as easily, and containers are much more lightweight than VMs. They don't have the same overhead. So that dynamic management is a key capability here, because it allows us to build systems that, like I said, that platform, and Kubernetes is one of those examples, right? It's a container orchestration platform. So you throw whatever containers you have at it, and it makes the whole thing work. It manages the pool of your machines, and it is aware of the applications you're trying to run on top, and it will then dynamically run those applications on that pool. That gives you great capabilities, right? For example, you tell the system how you want to run an application. Now, let's say one of your machines fails, right? In most cases, you don't actually have to immediately go in and try and fix that machine, because what Kubernetes will do is it says, well, I should be running, say, 10 instances of this container, of this application, but I just lost one because one machine, went away. But I know how to run this application, right? I have the container, I know what that looks like. And you gave me a spec as an operator, at a spec of how I should run that application. So it'll just spin up another copy on a different machine, and then you have 10 instances again, right? So it really helps, just talking about business outcomes again, it really helps with the resiliency, right? Meeting stricter SLAs, which are super expected these days, right? I actually still remember the early days of Twitter. Twitter was down a lot for a while. And in the early days, that was fine. But now everyone's using it. You got to run the thing 24/7, no downtime. And same is true for a lot of online services. So it allows you to essentially automate a lot of the operations that used to be manual, right? And many other things we could talk about here, right? It's gives you elastic scalability too, right? Let's say you have a business that in e-commerce, right? And Black Friday is around, a lot of people flock to your website, you need a lot more capacity overnight. It's very easy to do that if you standardize on containers and on Kubernetes, because again, there's a spec that defines how the application is run, and you essentially just dial up the number, or it can actually automatically do that for you, auto scale it based on some parameters that we set. Yeah. So that's essentially containers and container orchestration, which is done by Kubernetes, right?
No, I didn't want to interrupt you.
Sorry. Okay, I'll keep going. So then I should say, Kubernetes is an open source project. It was originally created by Google in 2014, based on the same patterns that Google uses to run their own infrastructure. So all the Google products that we know, right? Like Search and Gmail and YouTube and other things.
I think it was Borg, right? Wasn't it Borg, the internal?
That's correct. It's called Borg. Yeah, that's their own internal container orchestration platform. Open sourcing that one probably would never work, because there's just so many Googleisms in there. It's tied to a lot of their internal systems. So what they did instead is they built a new system from scratch that would work in the outside world, but uses some of those same patterns that they found, to be really useful and effective internally. And that's how Kubernetes was born, as an open source project. So they released that in 2014 and actually donated it to the Cloud Native Computing Foundation. Mm-hmm. In fact, he started the Cloud Native Computing Foundation along with us and a couple of others as sort of the independent owner of that intellectual property and that project, right? To manage that project as a truly independent open source project. And so, very quickly, a massive community started forming around this project. And that's what, we typically call the Cloud Native ecosystem. One of the fastest growing open source projects ever, maybe the fastest actually. And it spawned, this whole ecosystem of other projects around it, right? And so this is where I'm going to start talking a little bit about, what we do. So when you talk about containers, the first technology that comes to mind for most people is Kubernetes, right? Because it's really the platform, it's the foundation. on which a lot of these things run. But Kubernetes by itself is not a solution, like an enterprise solution that you would be able to take into production, right? It's a huge piece of the puzzle, but it's not a complete solution. So you actually need to add a whole bunch of other technologies around it to have something production grade. You need to add things for networking, for logging and monitoring, observability, for security and access control, right? And the list goes on. So, and then, the way folks approach this typically is they look at that Cloud Native Computing Foundation ecosystem. There's a map that's out there. It's called the Landscape, Cloud Native Landscape. And there's hundreds of open source projects on there that you can choose from to like build every single piece of your stack and put it in production, right? So I think that's important to note. There's a lot of different components that are involved, over a dozen or 24 maybe, to really get you something production grade. Now, I think there's like in general sort of three approaches that an organization can now take if they want to use containers and they want to build a stack on top of Kubernetes. Some organizations go the do-it-yourself route, right? They'll pick Kubernetes and they'll make all the technology choices around it. This is what I'm going to do for networking. This is what I'm going to do for storage and for metrics and logging and so forth. And they assemble their own stack. They do it themselves. Very few companies in the world can do that, right? It's basically the largest tech companies and maybe some startups that are able to hire the right kind of talent and that, frankly, have unique requirements that forces them to kind of do it themselves.
Yeah. What would be an example for a company like that? I'm thinking of a Netflix. I'm thinking of an Airbnb, maybe, right?
Exactly.
That type of company.
Those companies, right? Exactly. Yeah. Apple is a great example.
Yeah.
They're very active in the community and kind of doing their own thing. So they have unique requirements. They need to customize, right? And they have the talent. It makes sense for them. But for most everyone else, including mainstream enterprises, which is the type of customer that we focus on, it wouldn't make sense to make that investment because it is a large investment, right? You're talking about dozens of open source projects that are, they don't release at the same time. So often you have incompatibilities between the different things. So there's a lot of testing and validation and, that type of work that needs to go in to also like stay up to date and, because the market's moving really fast. There's new Kubernetes versions 3 times a year. So you really have to stay up to date. It's not just the, setting things up initially, but also staying up to date with the latest. So do it yourself, not an option for most folks. So then where you could go to is then you could buy a sort of proprietary platform that is built on top of Kubernetes or around Kubernetes, right? Mm-hmm. Platforms as a service is what they're usually called. Couple of options out there. The challenge, so now you get something that is, enterprise grade, it's fully supported, it's tested, validated. You don't have to do that work yourself. But you're also using something that is quite proprietary, right? That has, single vendor solutions in there and things like that. So that creates lock-in, right? What we hear a lot from folks is that from our customers, is they really want to align with the community. They look at the Cloud Native Computing Foundation and the projects within that as sort of the industry standard for, the components that should be included. And so, So if you deviate from that and you go with a single vendor solution, you're no longer aligned with where the community's going. You're doing something proprietary. So it's really going to tie you to that one vendor. What we try to do at Day2IQ is, sort of the best of both of those worlds, right? The best of DIY and proprietary. So we have a Kubernetes platform. It's called DKP, the Day2IQ Kubernetes platform. And the way it is architected is it's built on the best of breed open source components. So, if you were to go and try to do it yourself, you would probably pick exactly the same components that we picked, because we look at which projects are healthy, which ones are stable and production grade, right? And we assemble a stack out of that. But then you also get what you would get from a, more proprietary offering, which is full 24/7 support for all the components, right? So we don't just support part of the stack. You have any problem with, your Kubernetes platform, you call us, we'll help support the whole thing. And yeah, we do all that heavy lifting, all that dirty work of, integrating all the pieces and testing them and upgrading all the components to the latest versions all the time. We want to make sure. You touched on some of the government customers that we have, right? So security is of utmost important for us, right? There's a lot of work we put in to, scan all the components for security issues and, upgrade them. And so, yeah, I like to think of it as sort of the best of both worlds. It's the leading independent Kubernetes platform built from pure upstream open source components, but with an enterprise grade experience, 24/7 supported, fully tested and validated.
Yeah, that's a lot of background. So I want to unpack some of these things step by step that you talked about, right? So we talked about how Kubernetes came out of Google as an open source project. It's still open source, and I'm going to share actually my screen here in a minute. The adoption happened as part of an overall race to agility. I want to be agile. I need to ship more software, right? And so cloud native comes in there, or containers, orchestration, and so that's what drove the adoption. Now, Google donated Kubernetes to the Cloud Native Computing Foundation, right? But it's just like one thing. It's the orchestration layer. There's so many other things: security, monitoring, logging, and I'm going to share my screen here real quick. I think this is the landscape you were referring to, correct? It's the CNCF Cloud Native interactive landscape. Yeah. So there's a lot, and Kubernetes itself is here, right? That's the scheduling and orchestration part. Mm-hmm. And somebody or an enterprise that says, "Great, we're going to go cloud native and we're going to do containers and we'll use Kubernetes and the world will be awesome," right? So they're in for an unpleasant surprise, because to make it work, they have to pick, pretty much components from every bucket here, right?
Exactly.
Right. And that's like, even making the decision will take them quarters, right? And then hiring all that talent. It's impossible, right?
It is impossible for most organizations. It's really impossible. And one of the problems some people run into here that go down this do-it-yourself path is, they usually makes a lot of progress very quickly, because what's great about this community is there's so much free content out there, right? So you'll find these blueprints out there where people have chosen, a container runtime for you and a network and all that, and assembled that into a stack, right? So you don't necessarily have to validate and test all these components that you see on there. You can, probably find examples where someone's already done that. So you get something stood up pretty quickly, but where the real work starts is, the ongoing maintenance, what I mentioned before, right? These things put out new versions all the time, every single component, and they don't coordinate, right? They're independent open source projects. So how do you keep up? How do you keep your platform up and running once you have it? That's where the real work starts.
Right. That's what, it's like always in software, right? The adoption is easy. The maintenance is the hard part, right?
Right. And no one really wants to do it. People are more excited to build something.
Of course. And so, look, the cloud providers have their own distributions of Kubernetes, but really what I'm getting is a lot of lock-in, right? They have their own best interests in mind. Yeah. And really what I get with D2IQ is I get the best of all worlds, right? I can get the best of the open source ecosystem, but I don't need to worry about all the updating, figuring out if stuff works, like you guys do that. And then I get a full platform that gives me exactly what I want.
Yeah,
pretty much.
That's right. And the cloud provider Kubernetes offerings, we actually partnered with the cloud providers. Their Kubernetes offerings are very easy to use, right? They get you up and running very quickly. Mm-hmm. But they're fairly bare bones, right? You get Kubernetes and you get some of these other technologies from that landscape we just looked at. But you're still going to have to add a couple of other what we call day two add-ons, mm-hmm. To get something that's really production grade. And so that's actually where our company name comes from, Day 2 IQ, right? So Day 2, that DevOps concept of, you have day 0, which is your planning. Day 1 is you get things up and running, and day 2 is what happens afterwards, right? So, a big part of what our platform offers is these, what we call Day 2 add-ons. So all the technologies that you need to operate on Day 2, right? How do I monitor my clusters? How do I govern them, right? Set the right policies and things like that. And so, one of the capabilities we actually added in our 2.x product line is deep integration with those cloud provider Kubernetes services. So that we can now, lifecycle manage those from our control plane and, add all these Day 2 add-ons.
Got it. Yeah. And towards the end of the session today, I'll ask you a few tips or best practices for people who are just about to get started with Kubernetes. But now that we've covered your platform, I mentioned it, right? There's a lot of 3-letter agencies on your website, right? U.S. agencies, Air Force, U.S. Department of Homeland Security, and I've seen. I used to work for a company called Accenture, right? And we were successful by going to market by industry. And because industries have common needs, it can be JP Morgan, can be Goldman Sachs. At the end of the day, they have the same needs because of regulatory requirements or, because of customer needs. So can we talk a little bit about government customers? What's so special about them and why they've chosen D2iQ? And I assume maybe not all logos are on your website, but I'll run with the 2 that you have.
Yeah, there are a couple more that I can't talk about. Yeah. Yeah, it's really interesting. I think in the government, especially in the Department of Defense, there's really been a mindset shift over the last few years, right? Because traditionally how those folks operate is they work with the same types of companies again and again. It's those large, system integrators and, weapons, system manufacturers and folks like that. So whenever they needed something new, they just went to those same companies. And when it comes to software, they actually weren't doing much in-house at all. That usually went to someone like Booz Allen and others like that. And they would build the software for whatever the program is. So a few years ago, they really started thinking about becoming more agile, right? We talked about agility and how cloud native that's kind of the main thing that cloud native delivers. And they started to realize that, not only do we have a new type of threat nowadays, which is cyber threats, right? Cyber attacks that they need to learn to work with, but also just in general, any sort of threat has accelerated, right? In the wars in the Middle East, we heard a lot about IEDs, right? Improvised explosive devices and things like that. So those things, speaking in government timelines, those things appeared out of nowhere. And so they had to figure out a way to respond to that very quickly. And so they really just felt a need to become more agile, right? And went through this process to figure out okay, how do we do this? And they realized, all right, if we want to become more agile around software specifically, we need to pull a lot of that software development in-house. We need to build those capabilities. That's a key capability we need to own instead of just outsourcing it every time and being at the mercy of someone else, right? And then they started thinking about platforms too, right? How do we get agility into platforms? How do we spin up new projects faster than ever before? And related to all that too is how do we attract talent, right? How do we find people that want to write software at the Air Force, for example, instead of, going to a large tech company, right? And so all of that led them to open source, right? They said, well, if we want to build this stuff in-house and we need to be more agile, we can't be tied to any one vendor like we were in the past, right? Software vendor. So, we need to build this based on open standards, based on open source software. And that's also going to give us the agility and allow us to attract talent. So they really made a big bet on open source. And so, why they find our platform so attractive is specifically that philosophy that I mentioned, right? That we follow that third way, which is aligning with the community best of breed open source technologies. So they don't have lock-in, but at the same time, fully supporting that like, any commercial software vendor would. And alongside with that, I didn't talk about that too much yet, but we think to get to success here in cloud native, there are 4 pillars. We are primarily a software company. We sell software subscription licenses, right? So that's one, it's the software. But then it's also the support, right? Every single one of our customers, not just the government customers, everyone runs mission critical workloads, right? Stuff that cannot go down, that needs to be up, otherwise their business is affected. So we provide 24/7 support, but then we also provide training and services, right? So, and especially in the government, they didn't have a bunch of cloud native software engineers just sitting around and ready for the projects, right? They needed to hire them, they needed to train them. And so that's where we help them too. So really interesting to see that mindset shift in the government. They're really betting on open source.
Yeah, interesting. I want to go through your 4 pillars there: software, support, training, and services. I think I missed the 4th one. Which one is the 4th one?
Training and services, 2 different ones.
Oh, 2 different ones. Got it. Okay. Okay. Interesting. So what you're saying is that the decision by at least the US government to adopt Kubernetes was backed by, or there are 2 components in there. Number one, obviously they needed to become more agile, right? Mm-hmm. Because of a changing landscape of their, let's call them customers, right? Yeah. Right. And they couldn't do that with an outside vendor, right? Where you have probably an old ITIL, ITSM workflow and ticketing and all of that. That just doesn't work. So they had to build that in-house. And at the same time, that means you need to attract talent. You want the best talent. And today, the best engineers in the world, they do want to work with open source technologies, right? Because it can get their hands dirty. And so that was part of the decision-making why our government adopted essentially Kubernetes and D2IQ, right? Makes total sense. Yeah. So what are some of the special requirements that government has? I'm thinking, I'm sure they didn't just abandon their own old data centers, right? They may be running on Amazon, GCP, Oracle, Microsoft, God knows, all of them. So what are some of these specific, or aircraft carriers? Like, let's get some of the exciting stuff. Do you have a few examples to share?
For sure, yeah. And so it's actually pretty cool because a lot of this stuff is fairly public. So the US Air Force has a project that's called Platform One. Yeah. And what they did is sort of, this is another mindset shift that they had, is they sort of built this repository for the Air Force of sort of blessed software that any team within the Air Force could work with. And the mindset shift that happened there was sort of, in the past, their approach was always like, we're the Department of Defense, we're the Air Force. We're so unique, right? We have all these unique requirements. No off-the-shelf software will work for us. We need something custom. That's kind of was always their stance. And they've really moved away from that somewhat, I think. So whereas now they're saying, all right, let's actually use commercial off-the-shelf or open source wherever we can, and then sort of add our delta on top, right? Only solve the problems that are truly unique. Around that commercial off the shelf. And so, they do things, for example, like they have their own hardened and security scanned container images that their developers then use to build on top of, and things like that. But yeah, to the requirements, of course, security is of utmost importance to them, to any government customer. Obviously, they're a huge target. People want to hack them all the time, and this stuff needs to be secure. So a lot of the requirements are around that. So there's things like FIPS 142, for example, that's a government standard around encryption that you have to meet. Lots of things like that. There are lots of specific requirements around security. But one that I think is fairly unique to the government, but really influenced how we even architected our product, is you find a lot of air-gapped environments there, right? So air-gapped meaning, typically the extreme example is you have an environment that has absolutely no internet connection, right? There's nothing going in, nothing going out. It's an air gap, right? For the most secure, classified workloads and things like that. And then you have a whole spectrum of these things. Sometimes you have a little bit of an internet connection. You can go through a proxy or something like that. But A lot of times it's just completely air gapped. And so if you think about it, that's kind of a tall order because, we're talking about cloud, we're talking about cloud native. Well, the cloud is, or at least how most people use the cloud is, it's a public cloud, right? It's a public place. It's super well connected to the internet, right? And so you have all these assumptions that, for example, you can go to, something like GitHub and pull down code from GitHub, right? Or you can go to public container registries and pull down containers from there and things like that. You don't have any of that in an air-gapped environment. So if you think about it, you're trying to create a cloud-like experience in a place that has absolutely no internet connection. It's sort of antithetical, right? That's not how the cloud was designed. And so, but yeah, that is one of the most common requirements we see in the government. And so what we actually did is, because we've been working with government customers for so long, is when we designed our DKP product, we designed it with air-gapped environments in mind, or you could almost say air-gapped first, right? It has to work in those environments. Whereas what we see a lot of other vendors doing is it's the inverse, right? They make it work on the cloud first and then try to jam it into air-gapped. So you start with easy and then go to hard, and that doesn't really work.
Doesn't work. Yeah. Never works. Interesting. Yeah. And so, okay, so air-gapped environments and for secure, can you share what a secure workload is, or is like an example? Is that public?
Types of things that our customers are actually running on top?
Yes.
Yeah, I don't have too much detail on that. In fact, they don't share much about it with us either.
Okay.
Yeah.
Got it.
What I can tell you is it's a whole range of different environments, from unclassified to classified. There's the government has different levels of networks that meet certain security standards. That's all public, actually. Those are those networks documented. And so we have workloads in multiple different environments there.
Yeah. Okay. Any sound bites? Because I do want to talk about aircraft carriers and airplanes. Any sound bites there, or?
Yeah, well, actually, so I just remembered one workload that was actually that's actually public, and talk about that. It was at the U.S. Air Force, and it was very interesting because when the pandemic started, the Air Force also had to figure out how to deal with that, right? They also couldn't ask everybody to come to the office anymore, and so one of the things we did with them actually is they had to find a way to just communicate, right? They don't have Zoom set up to work from home, right? If you're in the Air Force. And so what they actually did is they set up a Zoom-like video conferencing system that is private to the Air Force, and they're running that on Kubernetes. So that's one of the things we helped them with, which was a huge success. We got tens of thousands of airmen and airwomen on that system within a really short amount of time. So they could work effectively together. Yeah,
it speaks to the capabilities of the platform.
Yeah,
and I'm glad we're making that shift to unique applications, because I think so. First off, we all know COVID happened, right? The pressure was on. People needed to change, all that good stuff, right? But even without that, I would argue that people or companies go through a maturity curve, right? They make the decision to adopt it. They built their first application. It works, yay. Move on to the second one, and they hire their team. They make the organizational changes that you said, and now they're having not one, two, maybe a lot of applications running, and that means they're also generating a lot of data. Mm-hmm. And so when we started this conversation, you talked about the concept of smart cloud native apps.
Yeah,
can you talk about that concept a little bit?
Absolutely, yeah. So cloud native applications have been around for about a decade now. And what we've really seen organizations go through is sort of an evolution in terms of what they're building and what those applications look like. And that latest sort of generation, I like to call it smart cloud native apps, because to me, it's really a shift. Like when we were going from, plain old cell phones to the smartphones we use today, which obviously was, a massive shift. Those phones are so much better. They have all these smart capabilities, and they have AI built in, right? A lot of the key functionality we use in our smartphones today is built on AI, right? Spell checker, personal digital assistant, the Photos app that automatically sorts your photos, the search on your phone, the list goes on. And so I think the shift that's happening from cloud native applications to smart cloud native applications is of a similar magnitude. So the journey that people have been going through is, when people first started building cloud native apps, they tended to be simple, microservices, stateless, didn't store any data. Because, when Kubernetes first came out, actually for the first 3 years, it didn't have any support for stateful workloads. It didn't have storage support. So all you could do is run stateless. But then in 2017, actually, Kubernetes gained what's called the container storage interface, CSI. Our engineers actually developed that together with Google. So that's the industry standard for attaching storage to containers. And now people could run more stateful workloads, right? Databases and things like that. So now they're building a lot of these data systems. A lot of folks are building, real-time data systems. Fast data pipelines is sort of a buzzword there. One example would be all the car companies, for example, are trying to get real-time telemetry from all the cars on the road and then build digital services around that, right? So they're setting up these real-time data pipelines. So now, like you said, right, these organizations are starting to collect a whole bunch of data about their customers, about their products. The next thing they want to do is then either gain insights into that data, right, learn something from it, or build new differentiated products around that data, right, to stay ahead of their game, to be ahead of their industry. So that's when they start leveraging AI capabilities, right? How do you gain insights into data? You do that with AI models like that. And so I've just seen this over the past few years in a number of our customers that they're going through this journey, right? Stateless first, then adding data capabilities, then adding AI capabilities. And so that it's really this new class of enterprise applications that has AI built in. And those applications, they wouldn't exist without AI. One great example is self-driving cars, right? Like without AI, the car wouldn't be self-driving, right? But you find these examples in a number of industries. We work with GE Healthcare, for example. They build massive medical imaging devices, MRI scanners, CT scanners, ultrasound, things like that. Those things, MRI and CT, they always were very compute heavy, right? There's a lot of 3D reconstruction, things like that happening. But there's so much opportunity for AI there. There's some research going on right now. It's called Fast MRI. They found a way to use AI to make MRI scans 4 times faster, which means they're also 4 times cheaper. They're maybe not 4 times, but they're significantly cheaper. And it's a much better patient experience, right? You won't have to be in the scanner for as long, which means it's going to be available for more patients, so we can use it, for much better patient outcomes and for more different types of, issues. So really just makes for a much better product, right? And so I see this happening in pretty much every single industry, that people are building AI into whatever product it is that they're doing, right? If you're applying for a loan today at your bank, there's an AI algorithm running behind the scenes that decides, what your loan terms are. Right? Every transaction you do with your bank, there's a fraud detection system that looks at that. That's powered by AI, right? So the very best products in every single category, they will have AI built in. It's going to literally be in every single product that surrounds us. And so those organizations have to build smart cloud native apps to deliver those products, right? So it's something I'm very excited about personally, because, in my career, I've always been doing infrastructure and machine learning stuff. I did some machine learning work in grad school and then at Airbnb before I founded this company. And so that's...
sorry to interrupt, Tobi. I don't think people realize how much street cred you have, right? Because you were an engineer at companies like Twitter, Airbnb, what else? Like that isn't enough, right? And it's also like industry defining product, Mesos, right? And so anyhow, I didn't mean to interrupt, but like you're too humble about your street cred.
Been a good run, yeah.
Yeah.
So yeah, I think whatever industry you're in, you're going to be building products that have AI built in. And so now the question is, if you're building these AI products, right, how do you architect them, right? How do you build the cloud services, the cloud native applications that power these offerings, right? Because you're going to have to figure out how to not only run what you've already done before, if you've been using cloud native, right, run microservices, run data services. Now you have this new type of workload, which is an AI workload, right? Well, then the question is like, okay, I'm using Kubernetes, I'm using cloud native platforms to run my microservices and my data. What do I do about AI? Do I run that differently? Like, should I put that in VMs or do something else? Well, generally, you don't want to have operational silos, right? You want one way to run things. So just makes sense to standardize on one platform. Well, it turns out that actually Kubernetes and containers and cloud native are a really good fit for AI workloads too. Mm-hmm. And in AI, you sort of have two different parts to it. There's the training, which is where you build models. And then there's what's called inference, which is, the model exists and, new data comes into the model and the model's, either making a decision or giving you some output. So there's these two different phases. In the training side, AI needs vast amounts of resources, right? You're training a model on huge amounts of data. You need a lot of compute. And those training jobs, they spin up quickly and then they shut down again, right? Like based on what your data scientists are doing. So often you have humans competing for the resources and you want to, run within your budget and stuff like that. Well, turns out that's exactly what Kubernetes is great at, right? It has a scheduler. It can help you do that and manage those resources for you. And then on the inference side, that's also a really good fit because one thing that's new here around AI is a relatively young field, right? And there aren't many best practices around, well, how do I run a model in production, right? What does my deployment pipeline look like? How do I get that out there? How do I monitor it? How do I make sure it performs and all that stuff? Well, turns out a lot of those best practices that we have for other applications like microservices, we do things like continuous integration, continuous deployment, and we do observability. Turns out you can use all those existing tools and just apply it to AI workloads too, to those models, right? So that really solves a huge need for these AI workloads. I've got some statistics on that too. It's actually most AI projects fail on their way to production. You might think that, well, AI projects fail because, people, don't understand their data or they're not able to build these super complicated models. That's actually usually not the case. Folks in whatever vertical they're in, they're usually experts in the data they have and know kind of what they want to do with it, but they're not experts in running large production systems, right? And so,
yeah, right.
And so those are just a couple of reasons for why it makes sense to run these AI workloads, on the same Kubernetes platform that runs all the other stuff. It also just conceptually makes sense, right? Like it's all part of the same business application, right?
Yeah.
Why would you run that on 3 different platforms? You want to run it on one, right? And so that's one thing that we've been focused on too, is really being the best platform for running these smart cloud native apps, not just simple microservices, but really these sophisticated smart cloud native apps, because they really come with their own challenges, right? They tend to be fairly complex workloads, complex from an operational perspective. They tend to run in different environments. And so we automate a lot of that and try to make it really, really easy for folks and sort of level the playing field in a way, right? Because obviously the best tech companies in the world, they know how to do that stuff already. But we think every organization is going to need to figure out how to build smart cloud native apps if they want to compete in the future. And so, we're giving them the right tools to do that.
Yeah, that was my, as you were sharing these stories, that was my reaction. We're about to enter another arms race. Like the ones that do not build these cloud native, the smart cloud native apps, they're going to be left behind.
Absolutely.
Right?
Yeah. It's going to be another, it's going to be like Netflix and Blockbuster again.
Yeah.
If you think about it, Netflix initially, they were mailing DVDs, right? It wasn't that different from Blockbuster, right? They didn't have stores, they were mailing things, but both were doing DVDs, right?
Yeah.
But then Netflix said, all right, like we're going to get into the streaming thing and just innovate. And Netflix, was one of the early adopters of cloud and, and really not just figuring out how to build a great consumer experience, but also figuring out how to operate large online services, right?
Right.
And so that's the kind of leap I think a lot of leaders have to do, right? Like technical leaders, CIOs, CTOs, right?
Yeah.
Where they have to say like, well, in order to compete for us in the future, we have to create capabilities in-house around, building and delivering these smart cloud native apps if we want to stay ahead.
Yeah, in fact, and before we wrap up, I would love to dissect those different capabilities and steps, right? Let's pick, I don't know, we can pick a Tesla as an example. But the way I would look at it is like, okay, you have the car that's generating data. Right? Mm-hmm. I need to get that data off the car, right? The telemetry, whatever data sensors, whatever data they collect, right? I need to store that somewhere. I need to probably label it or somehow catalog it. And now that becomes the foundation for my training my algorithms, correct? Right? That needs to happen somewhere. Then that's how I train, what's the word? The predictability of the model, right? And then I need to apply it, right? So it's the inference part. I need to send it probably back to the car or whatever decisions, like, I don't know. So can you walk us through these different components a little bit and tell us sort of the technology decisions that teams need to make?
Yeah. There are a lot of technologies involved. So I'll just touch on a few.
Yeah.
But, basically, I talked earlier about, how we architected our DKP Kubernetes platform, right?
Right.
Best of breed open source components. I'm convinced that for building these smart cloud native apps, all the AI and machine learning components, that's also going to be based on open source for most companies. And the reason is simply this, right? I talked about how Kubernetes was one of the fastest growing open source projects ever, so much innovation. So if you want to be ahead of the pack, you want to be an innovator, betting on open source is a really good strategy, right? To tap into that innovation that's coming out of the community, right? And in the ML and AI case, it's actually goes a bit further than what's happening in infrastructures, because there are even open source models now that you can choose from, right? So if you let's say you want to build the next Tesla, right? You want to compete with them. You don't have to start at zero. There's already models you can pick off the internet that can detect cars and bicycles and humans, right? And you can build based on that. So open source is a really good strategy that a lot of people are using for the AI applications too. So that means a lot of these components for that AI pipeline, machine learning pipeline, and you did a great job describing it at a high level, they're also open source, right? And so what we did for our machine learning offering, which is called Captain, it's a product that sits on top of our platform. We followed the same approach that we did for the platform itself. Pick the best open source pieces and integrated it into an enterprise offering, right? So what are the different pieces? You start with the data. Data comes off the car or something like that. You need to store that data somewhere. Typically, there's like 3 different types of data. There's structured data that usually goes to a SQL-like database or maybe a graph database, something like that, different types of databases. You might have unstructured data. So that's more, log files, things like that. Goes to a large object store. If you're on the cloud, each cloud has one. On-prem, lots of different options there. And then third is streaming data, right? So for example, live telemetry, what's the car's location every 10 seconds, things like that, right? So you have different types of data stores for that data. The next step is, as a data scientist, you need to get access to that data. And often there's a lot of data transformation that needs to happen, right? You need to clean up the data. Let's say, very simple example, let's say you want to categorize your user's age into different buckets, right? You don't want the actual number of the age, but you want to say, 0 to 9, 10 to 19, 20 to 29, bucketize it. So there's transformations you need to do on the data. People use Apache Spark for that quite a bit. That's part of our offering too. So you do these data transformations, and then one relatively new technology is not that widely used yet, but I think is really key, is what's called a feature store. Mm-hmm. So it basically stores these transformations or these definitions for what your data looks like, and just provides a single interface to everyone in the organization. So you don't have one person has a 20 to 29 bucket and the next one has a 20 to 25, and then it just doesn't match up. So you try to have these definitions in one place. That's called a feature store. Then you interface with that as a data scientist from a notebook environment. So a notebook that's essentially your development environment where you work as a data scientist. Jupyter is, I think, the most popular tool there. And, Python is probably the most widely used language for modern data science. So you use Jupyter notebooks, you use Python, and then what's called a machine learning framework. So or AI frameworks. So TensorFlow and PyTorch are the two most popular ones currently. One's out of Google, one's out of Facebook. And so people, data scientists then build their models in Python using one of these two things. They pull in the data. Now they train the model, right? So these frameworks have capabilities built in for running these training jobs, which can run for days and, on thousands of machines, depending on how much data you have. And then you do another step in there, which is called hyperparameter tuning, right? So typically you don't just build one version of the model, but models have different parameters. It can get super complicated. So you build dozens of different versions of the model with different parameters, and then you pick the best performing one, right? So once you have that, you now have a model. Now that needs to go out into production. Typically, what we recommend is to build a continuous delivery pipeline that automates all this. Our Captain product is based on Kubeflow. It's another open source project that actually integrates a lot of these pieces, like TensorFlow, like PyTorch, and then it has a workflow tool that lets you orchestrate these different steps that you need to go through on the way to production. And then you use something like, every one of these frameworks has a serving component built in where you actually then run the model as a service. TF serving is the one for TensorFlow, for example. So you put it out there, and then one of the things we did is in Captain is this step. Again, this is where a lot of machine learning projects fail, is from model to production, because this is really where it gets complicated, because the training and the inference often happen in different places. Usually you train on the cloud because you have quasi unlimited resources. But then, like you said, the model might need to go on a car, or it might need to go in an edge location, right? We work with manufacturing customers, for example, that need to run their models in factories, right? So how do you get it into a specific location on the edge? We actually abstracted all of that away with our Captain SDK. So as a data scientist, you just write Python and magic happens behind the scenes and gets your model to the right place. But yeah, then it runs in the production environment, could be edge, could be cloud. And then that's where the day two operations comes in again, that I talked about earlier, right? Like, how do you measure the model's performance? How do you make sure it responds fast enough, things like that. So you use sort of your observability stack that is also built into a platform. We like Prometheus, Grafana, and those are some of the most popular tools in the ecosystem to do that.
So that's the insight, right? So because the model needs to run in a different place than where you train it, it may run on the car at the edge, right? And so that just introduces a whole bunch of new complexities.
That's right.
And Data2IQ's platform, Captain, right, just caters to that or solves that problem. Mm-hmm. That was great. So, okay, to close then, Tobi, we talked about so many things, but smart cloud native apps. If a company wants to get started with it, and it's day zero now, to use that language, right?
Yeah.
What are your recommendations in terms of steps, what they should do? What's my next step?
Yeah, there are a lot of steps. I think the first thing, is think about what your strategy there is. in terms of the technologies you want to use, right? And obviously what I recommend, what we recommend is to bet on open source, right? Because it gives you just unparalleled speed of innovation, right? So make that call, right? Or maybe for some problems, maybe you don't need open source. Maybe there's like a cloud service that does exactly what you need. But I think in most cases, you want that speed of innovation. And then it's really about finding the right partner, because we talked about those 4 pillars earlier, right? There's software, support, training, and services. You're going to need all of it. So I think you really want a partner that can guide you through that process and can help you upskill your team or make the right hires, architect. And so, I would say it's not different from like any other IT project in that sense that, you gather requirements and figure out what environments you need to run in, the scale you need to run at, and things like that. Those are all things we can help with, or, depending on where customers are in their maturity in their journey, they might want to do these things themselves too. There's obviously, that a group of companies too that want to do it themselves. And there's great community projects out there that you can get involved in, like TensorFlow, PyTorch, and others, if you want to interact at that level. But yeah, I think finding the right partner is key.
Yeah. Sherpa that
goes on that journey with you.
Yeah. I think in today's world, it's just impossible to do it all in-house. The world is moving way too fast for this, right? So you need experts on your side. That's great advice. Tobi, any parting thoughts, or otherwise? I think this was a great conversation. Thank you so much.
Yeah, thank you, Lars. I really enjoyed it. I think we covered a lot of ground, touched on a lot of different topics.
We did.
I love talking and thinking about the future, and I love talking about infrastructure and AI and machine learning. So, this, and like I said, I think this is something every organization needs to really build a strategy around, right? I think if you're an executive and you don't have an AI strategy, I think you're going to get in trouble.
You will be in trouble. I much agree. Yeah, I feel there's a second podcast in here where we talk about just about smart cloud native apps. We covered a lot of ground today. Tobi, this was super helpful. Thank you so much. And I hope to see you another time on this podcast here, this video podcast.
Absolutely. Thanks again for having me on. It was a pleasure.
Thank you, Tobi.